Okay, in this video, we're going to go right into some basics of trigonometric identities and different formulas and whatnot, starting at the very, very basic parts of them and then kind of expanding them out from there. So the first thing I want to do is take a look at all of these guys right here and how they related to the unit circle. So let's go ahead and get some facts that we know filled out from lessons past. Okay, so these were the definitions when we had right triangle trigonometry in the past classes, and basically it had to do with the actual angle theta and its position from, or I should say the side's positions from that, the opposite side, the adjacent side, and the hypotenuse. Okay, so when we started to line things up, we also noted that any point that's going to be on the unit circle is going to be x comma y, and we know that the side that is going to go horizontally to meet the x value is going to be x, and the side that is going to go vertically to meet the y value is y. And to make it a unit circle, because its hypotenuse is 1, we always keep that as 1 as a quality of life thing. And so what we did is that we filled in all of these definitions right here with x's and y's, so we can go back and forth between the actual trig ratio of theta, whatever trig theta it is, and move our way to x's and y's, which I'm going to list right here. Okay, so they look like that. So that is how far we made it, and what we're going to do to start off in this video is that we're going to introduce putting these x's and y, basically their values from the unit circle into the unit circle definition to create new trigonometric identities here. So we're going to start off with sine squared plus cosine squared is 1. And so what we want to do is that we want to... Okay, so let's start proving out this first identity right here and showing why it is sine squared theta plus cosine squared theta is 1. So what we're going to do is that we're going to start with our equation of the unit circle, okay? And from there, what we are going to do is that we're going to take these values right here, oops, we can probably just, those values from x and y, and we're going to plug them in for sine and cosine in this guy right here, okay? So what we do is that sine is actually y and cosine is actually x in this case, so we're going to get cosine squared theta plus sine squared theta equals 1, okay? And then for quality of life, most people say switch them around, sine squared theta plus cosine squared theta equals 1, okay? So that basically proves out this identity right there. Now, there are two other ones that are a little bit trickier to memorize out for most students, but I'm going to show you a way to go ahead and knock those out, just using what we know about all of these other good trigonometric identities here, and start to piece them together. Before we do that, I want to go ahead and zap on over to the bottom right hand square, and I want to make sure that we got these guys down first, because that's going to be integral to deriving out these other two guys right here, okay? And all the pieces will make sense in a moment, okay? Now, the reason why tangent theta equals sine over cosine is that if we look at tangent theta, the definition, and let's go ahead and just knock these both out at the same time, and cotangent theta is that if we look at the trig identities here, is that we're going to see that tangent is y over x, and we're going to see that cotangent is x over y. So let's transfer those on over. Y over x and x over y. So now we know Again, that sine is y and cosine is x. So therefore, when we substitute them in, we're going to get the tangent of theta equals sine theta over cosine theta, and cotangent is going to equal, I don't know why I'm making my theta so sloppy, is going to equal cosine theta over sine theta. What is going on with, there you go, sine theta. So, at any rate, what we're going to do is that we're going to use those to go back to the Pythagorean identities now and see if we can come up with a slick way to memorize out, again, this guy and this guy. Okay, so to prove out the property tangent squared theta plus 1 equals secant squared theta, what we do is that we start with just the simple sine squared plus cosine squared equals 1. And what we want to do is that we think, okay, well, how do I create a tangent? Okay, and we just learned that tangent is sine over cosine. So what we can do is that we can multiply the entire thing by 1 over cosine squared theta, and when I go ahead and I distribute that into each term, I get cosine squared on the bottom of each of those, and now I can start to use the identities on this page, or this page right here, to knock everything out. Okay, so here we go. Putting all the pieces together, we're going to get sine over cosine, which is going to give us a tangent theta, and then we have cosine squared divided by cosine squared, which is going to give us 1, and we got 1 over cosine, which we know that 1 over cosine is the reciprocal value, which is going to give us secant squared theta. And there we go. We have proved out the second one. Okay. So what we're going to do is that we're going to use the same technique for the last identity. And we notice that we need a cotangent for that one. And so to get cotangent, we know that we're going to have cosine over sine, as we see right here. So therefore, what I'm going to do is that I'm going to multiply the entire thing by 1 over sine squared theta, and when I distribute, oops, that is going to give me, and I think I missed with that second one. I don't want to think it's a coefficient here. There we go. All right, so distributing that in, we're going to go ahead and get hopefully what we need here. So this is going to give us sine squared divided by sine squared, which is going to be 1, plus cosine over sine, which is going to give us cotangent squared theta, and then 1 over sine is going to give us cosecant squared theta. Okay, so that brings us through our basic definitions, our Pythagorean identities, and our tangent identities. So what we're going to do is that we're going to introduce some other identities, and then we're going to take a look at how do I use these trigonometric identities to rewrite something that's convoluted into something different, just for whatever reason that you may need to in the future. So see you in the next video. Okay, for this video we're going to take a look at the even and odd formulas, and I'm going to demonstrate this using just a real quick unit circle reference here. And so we want all, and then we have sine, tangent, and cosine over here. And if you recall, if the terminal angle, or I'm sorry, the terminal side lands in those quadrants, then that particular trigonometric ratio and its reciprocal are going to be positive. So let's take a look at, if I have this angle right here, okay, that's going to be a positive theta. And we know that if I want a negative theta, it would just be going in this direction. So basically it's going to reflect on over the x-axis. So basically all this is saying is some stuff that I think we already knew. So let's take a look at this first one here and put all the pieces together. So sine of a negative theta equals negative sine theta. Now, we knew this when we were going to go and when we were doing out trigonometric identities, okay? I'm sorry, trigonometric ratios. And to model this is that if I had the sine of, say, a negative 30 degrees, the way that we did that is that we knew that it would go back, say if theta was a negative 30 degrees there, and it would land in cosineville. So if we were going in the opposite direction, all right, this direction, it's going to be a positive because that's where everything for sine is going to be positive. But if we go in the opposite direction, it's going to land in a quadrant where it's going to make sine negative, okay? So that basically means is that we knew that that was going to be negative, okay? And then we just took the absolute value of the reference angle, okay, the angle that is going to the terminal side with the closest x-axis there, and that is just going to be the sine of 30 degrees, which is going to give us a negative 1/2, okay? And so this is just stating all of those in the same general form, okay? So sine and tangent work out the exact same way. The only difference is going to be this business of cosine, and let's take a look at why that is. So if with cosine, if I started off with cosine of a negative theta, the way that we could take a look at that is that cosine would be positive here, and cosine, if I go in this direction, is going to be positive as well. So if I move in a positive or negative direction, cosine is still going to end up being positive if it's its reference angle. So we would just have the cosine of theta. To put some numbers to that, we can again say cosine of a negative 45 degrees, okay? So the cosine of a negative 45 degrees is going to be, right, we know that it would be going in this direction right here, but it would still be positive because it landed in cosine's quadrant. So we could just say is going to be the same thing as a cosine of 45 degrees, which we know that both of those are going to be root 2 over 2. So that's kind of a roundabout way of why those worked in regards to the unit circle. And it is the same thing works out for the reciprocals over here as they did for their counterparts. So that's how you do that, and we're going to jump into doing some trig identities, rewriting some trig expressions, and trying to get them look like one other side of their equality there. So you'll see when I get there, or when we get there. So see you in the next video. Okay, so this is our first trig identity that we're doing. And when you're doing an identity, which is right here, is that you're trying to get one side to look like the other side. So for example, you want to maybe see how you're going to use all those trig identities that we just learned to make that look like that, okay? And there's some guidelines that you want to play by, just as a quality of life thing, that it's going to walk you through how to make the best use of your time and efforts trying to get those sides equal to one another. So you always want to choose a side with more work to do. The reason being is that it's easier to shrink things down than to expand them out in a trig identityville. You want to work with one side only, so you pick that side that has more to do and try and get it to this simpler looking side. If you're stuck, you can change everything, the sine and cosine, because that's what tangent, cotangent, secant, and cosecant are all made up of. So that's kind of like the basic building blocks. So if you have to break it down to the basic building blocks, that's a good way to go as well. And definitely try something. You just never know when the whole thing might fall apart. Okay. So the way that I'm going to do this, first one here, is that I'm going to rewrite it larger so I got some room to work. Okay, so looking at the rule here is that we want to work the side with more to do, and it looks like that left-hand side is going to be the one that seems like there's more to do. This is just sine squared, so there's not much really we can do with that. But it does look like we can work this left-hand side and maybe take a look at trying to get that thing equal to sine squared. Okay, so we separate them out. We choose the left-hand side to try and make it look like the right-hand side. So the first thing that I'm going to do is that, looking at this, there's a bunch of different ways that we can go, but what I'm going to do is that I'm going to be able to, since we're dividing by a single term, I can break this up into two separate fractions and go the secant theta over secant theta minus 1 over secant theta. Okay? And again, the reason why we can do that is that, say if I had 2 plus 3 over 7, okay? That'd be the same as going 2 sevens plus 3 sevens, okay? So that's what I just, as long as you are dividing by a single term or a monomial like that, you can break them up into two different ways, okay? So I go over here and I'm like, all right, well, I know that's good news because I know that this is going to give me a 1 because it's divided by itself. And this 1 over secant, I know by definition is going to be cosine. So now I have 1 minus cosine squared theta, okay? So I'm looking at this thing, and this is where we have to be a little bit kind of, we have to be, how should I say, look at this in a clever fashion, okay? So what I'm going to do is that I'm going to go back to something that we learned that was going to be sine squared theta plus cosine squared theta equals 1, okay? And so anytime that we have 1 in a cosine squared or a sine squared, we know that we might be able to use this technique. Now, this is going on off to the side in your head. This is not part of the work or anything that we're showing right now. And so if I look at this and I say, okay, well, how can I rewrite this such that it looks like 1 minus cosine theta? And I can do that by subtracting the cosine theta from each side. And I'm just going to put cosine theta like that. And that is going to give me sine squared theta equals 1 minus cosine squared theta. Okay? Now that's good news because this and this are the same. So since they are the same, I'm going to use substitution. And I'm just going to say that this 1 minus cosine squared theta is actually sine squared theta by definition. Okay? And now I'm happy because if I look, the left-hand side is balanced with the right-hand side. I have followed all the rules over here, or I didn't need to go ahead and do the last two, but I definitely did the first two. And that's our first identity there. So it's rewriting this in order to get this. Okay, so let's take a look at a few other examples, because really the only other way to get good at this is to see some different techniques, and so I'll meet you at the second example. Okay, this guy seems like there is a lot to do on that left-hand side. Okay, this part over here. This part over here seems pretty well set. There's not much to do. So what I'm going to do is rewrite this to give myself some room, and then we will start putting things together. Okay, so we did agree that the left-hand side looks a little bit nicer to work with. And what I want to do is that I'm going to separate these guys out, and I'm going to use a technique that we used earlier in the class to add some fractions. So if I had 7 over 8 plus, let's see, 2 over 3. If I wanted to add those up real quick, I could multiply those guys, give me 21, and multiply those guys plus 16, all over multiplying those guys, which is 24, and that's going to give me, let's see, 37 over 24. Okay, and that's a quick way to add fractions. Now, I'm going to do the same thing here, except I'm going to have a sign kind of sprinkled in here, and I'm going to multiply those out. So that's going to be 1 times sine theta, which is just going to give me 1, and I'm going to write it all out just for so everyone can see what I'm doing. 1 plus here, and I know we don't need the 1, but I'm doing it anyhow just so for ease of understanding. Okay, all over this guy, which is going to be 1 minus sine theta times 1 plus sine theta. Okay, so now we can start to knock these things out, and let's take a look. All right, so this guy, we might want to FOIL out this bottom part right here. Okay, so I'm going to FOIL this out to the right here. So I got 1 minus sine theta 1 plus sine theta, and after I FOIL all this out, I'm going to do it out real quick. Okay, there it is, all FOILed out, and it looks like the center is going to go out, and I end up with, on the bottom, 1 minus sine squared theta. So let's go back and write that. So now I have this large division bar, 1 minus sine squared theta, okay, all over, and just kind of looking up top, it looks like these signs are going to cancel out, right? Because these ones don't really mean anything here. And when I add those up top, that is, since those cancel out, because I'm going to have sine theta minus sine theta, which is 0, and then I got 1 plus 1, which is just going to give me 2. Okay. Now, what we're going to do is that we're going to use the same trick that we did in the previous example, which to help us knock out this last part right here. So if we remember, and I'm going to do this out real quick, I'm going to show you guys some shorthand for the Pythagorean identities here, is that if I have sine squared plus cosine squared equals 1, and I want to try and substitute this out, that means is that I can subtract the sine squared from each side and get cosine squared equals 1 minus sine squared. Okay, so I know that that bottom part just equals the cosine squared. So I'm going to rewrite that as 2 over cosine squared theta. And then finally, I know that if cosine is in the denominator there, that I can use the reciprocal identity, because 1 over cosine, if you remember, so we'd have, I'm going to just write it over here, 1 over cosine equals secant. And so therefore, since I have 2 of them on the bottom, I'm going to have 2 secant squared theta. Okay, and you notice at the end of the day, I got those to look like one another, so I know that I did the identity correctly. So that's another example, and let's do a couple more to get our chops up with these. Okay, this one looks like it's got a lot of stuff going on, and so it looks like that left-hand side is real tempting here. And so what I'm going to do is that, again, I'm going to rewrite, and I'm going to pick on the left-hand side here because it looks like there's more to do here. And one of the things that I want to take a look at is this business of a quadratic imposter, it looks like. And so if I look at this part right here, okay, and what can I do with that? It looks an awful lot like if I were to substitute out, let t equal sine x, I can go ahead and put t squared plus 4t, but not 4t, haha, like that, and factor it out, okay? So after I factor that out, I need 2 numbers that are going to multiply to 3 and add to 4, so I get t plus 3t plus 1. So that means is that when I substitute sine back in, I'm going to get sine x plus 3 sine x plus 1. So let's go ahead and slip that back in there, and I'm going to do a cheaty face method and go ooh, right there, and that is the top all factored out. Now, the cosine squared on the bottom looks like, well, what am I going to do with that thing? And I notice that I have, it's just cosine squared by itself. I can probably get away with doing something with the Pythagorean identity. So what I'm going to do, and I'm going to do it in the shorthand, I'm going to go sine squared plus cosine squared equals 1. So if I want cosine squared all by itself, I'm going to subtract sine squared from each side, and that's going to give me cosine squared equals 1 minus sine squared. So I'm going to put that in the bottom there and go 1 minus sine squared x, and it looks like we've made some headway here. Now, what we can do with this right here is that we can use the difference of two squares to factor that thing out, okay? And if you remember the difference of two squares, if I wrote it like that, we can rewrite that as that bottom part right here, okay? And the top is going to stay the same. So what I do at this point is I try and look, because I got a lot of good stuff going on here, and I see some stuff that I might be able to cross out, and I'm thinking, okay, well, what do I want that right-hand side to look like? And I'm like, oh, you know what? This guy right here, these are the exact same thing. And so I'm going to cancel those out and rewrite the top by switching just a 3 and the sine x around, and that is going to give me what I need, I believe. So I have 3 plus sine x all over 1 minus sine x, and look at that, we got it on both sides, and so we're good to go. So that is a good kind of like a lot of different techniques mixed in with there. And best thing to do is this, we're going to get some practice and just get your hands dirty with it. Run into some barriers, but remember, if you keep all of those 4 things in mind, that it usually shakes out. You might get stuck sometimes, and that's okay. But the more exposure that you have to it, the better off you're going to be. So thanks for watching, and see you in the next video. Okay, here we are at the next example, and we have this guy right here. We got a tangent, a cotangent, a secant, and a cosecant. And then we got some addition going on, and then we got multiplication. So we need to come up with a strategy. So what I'm going to do is that I'm going to rewrite it to give myself some more room, like I have been. Okay, and kind of discuss some strategy here. First things first is that oftentimes when we have addition or subtraction on one side and then having multiplication on another, the addition and subtraction side might be the side that you want to pick, because oftentimes if we get like maybe common denominators, we'll have some other stuff going on with it, and it could unfold a lot nicer than maybe this side. So yeah, well, let's go ahead and pick the left-hand side for giggles and see what happens here. Now, we also want to take a look at rule number 3, is at if you are stuck, change everything to sine and cosine. And in this example, we probably want to do that because there's just not a whole lot to do, okay? We got, and basically, as is, we're kind of like stuck unless we rewrite it. So let's go ahead and rewrite the following. Let's rewrite tangent as the sine over cosine. And let's rewrite cotangent as cosine over sine. And so now we're like, okay, this gives us a little bit more to go on because now we have some stuff to do. And I'm going to do like those shoelace technique that we looked at in the other video. So I'm going to get sine times sine, which is sine squared. I like that so far. Plus cosine times cosine, which is cosine squared. And so I'm really liking that because I can already see that that's an identity there. And then we have sine, let's put, cosine, sorry about that, times sine, the last part of the shoelaces here. Okay. So now I know that using the identity of sine squared plus cosine squared equals 1, I can just turn the entire top into 1. And I like that a whole lot because now I have kind of like peeking over on the right-hand side. I think I have something that is going to work out nicely. So looking at the right-hand side and just seeing where I need to go, I have a secant, and I know that if I take cosine like this reciprocal right here, that's going to give me a secant. So I like that a whole lot. And I also know that this cosecant right here, that's like 1 over sine as well. So I know that that is going to be cosecant here. So we can see, and I wrote that kind of crappy, so but anyhow, we can see that just by changing everything to sine and cosine, and the whole thing of like addition and the way that it plays out with common denominators sometimes lends itself to new forms, and it helps, just kind of expedite the strategy here. And remember, try something. If you did the right-hand side and it just it wasn't working for you, then try the left-hand side and see if something shakes loose. So that's how you do that one, and I will see you in the next video.